All right, guys, I'm going to talk quickly through 6 and give a little hint on 7, and then I'm going to kind of work my way through problem 8 from the last page of the quiz review packet. I'm going to do A and B. I probably won't do C. We'll see how much time we have here. I don't want to make this video too long. So just as we talk about 6 real quick, it says a certain material decays at a rate of 0.54% per year. It doesn't matter what the material is. And make sure that you remember that if you're going to turn this percent into a rate, you've got to swing that decimal place over 2 places. So how much of the material will decay in 11 years? You've got your time, you've got your initial amount, you've got your rate, so you should be fine and doing fine with that one. All right, 7 though says some material decays at the rate of 0.099% per year. Again, you've got to remember to do this with your rate. But the problem people are finding is that they don't know the principal amount. They know that the total amount is going to be 30%, but they don't know how much there was initially. It's implied when we're talking about these materials that if it's decaying, we're wondering how long it took the material to get to 30%. It started with all of the material or 100% of the material. So once you know that, you should be able to plug in the values you know. You're going to solve for T. Now let's talk about 8. Seth's parents gave him $5,000 to invest for his 16th birthday. He's got 2 investment options, and he's going to pick between them. Option A will pay him 4.5% interest compounded annually. You see that word compounded? That's a big deal. That means you're going to be dividing by some rate, or by some rate here, it's annually. So it's going to end up being 1 there. But option B is 4.6% compounded quarterly. So that is going to affect our value. So A says write a function of option A and option B that calculates the value of each account after n years. So we're talking about n years. N is kind of our time here. So function A is going to be A as a function of n. And that's going to be our total amount. He starts with his $5,000. He's going to be growing that amount over time, and his rate is 4.5%, which we have to turn into a rate. It's going to be 0.045. All right. It's being compounded, though, annually. Now, compounded annually means once per year. So really, even though it's being compounded, it doesn't affect anything about what we do because you're just going to divide that rate by 1. Then you're going to take your time, and you're going to multiply that by 1 as well. So 1t really doesn't change anything. That's still just going to be t. I'm sorry, though. We don't want to use t. We're going to use n because it's giving us n as our time. So n years, 1n, or just n. All right? Now, when we're talking about b as a function of n, still starting with $5,000, still growing. The rate is a little different, though. Now we have 0.046, and we're compounding it quarterly. So we're going to take that rate and chop it up into fourths. Now, the interesting thing about cutting it into 4 chunks is now every year we have 4 quarters. So how many quarters is that total? Well, it depends on the years, but we're going to have to multiply it by 4 in the end. So those are your 2 functions. Now, B asks, Seth plans to use the money after he graduates from college in 6 years. So what he wants to know is, which one should he go with? How much more money is option B going to earn him over that 6-year period of time? So the problem we're going to solve is, what is B of 6 minus A of 6? Now, in order to do that, we've got to find B of 6. We've got to find A of 6. So let's do B of 6. B of 6, we're just going to use that function we created, 1 plus 0.046 over 4 times, or to the 4 times 6 power. You're going to throw that right into your calculator. And when you do, you will get an answer of, give me just a second, $6,578 and 87 cents. So that's what option B gets you. So we can plug that in. And what does option A get us? Well, A of 6 is going to be 5,000 times 1 plus 0.045 divided by 1 to the 6th power times 1. And when you plug that in, you'll get $6,511.30. And when you do your subtraction, you'll end up with $67.57. So he should go with B because it's going to earn him $67.57 more than if he were to go with A. Let's talk about C, because C is where these logarithms come into play. We got a little bit of time. Algebraically, determine to the nearest tenth of a year how long it would take for option B to double Seth's initial investment. So we're going to use B of n, that's our time. We still have $5,000. We still have 0.046 over 4 to the 4 times n. We're going to solve for n. Now, when it doubles our initial investment, he's going to end up with $10,000. That's too many zeros. $10,000 equals 5,000 times 1 plus 0.046 divided by 4 to the 4n power. So in order to solve for n, we want to unlock this exponent. We can't do that until we get rid of the base, and we can't get rid of that base until we eliminate this 5,000. So I'm going to use division to get rid of that $5,000. And when we divide 10,000 by 5,000, we get 2. Now we have 1 plus 0.046 over 4 to the 4n. Now it might be easy for us to simplify that. So I'm going to rewrite this just so that we don't have to keep writing that addition problem. Because 1 plus 0.046 divided by 4 is 1.0115 to the 4n. Now we want to unlock our exponent. We can't do that though because of this base. So the question we're asking is, to what power must I raise 1.0115 to equal 2? Now let me write that the way I said it. To what power must we raise 1.0115 to equal 2? And that what power is 4n. So to get n by itself, divide both sides by 4. Plug this into your calculator, and you will get that n equals 15.15 years. That's how long it'll take.